Good day, everybody. Thank you for joining us on the second day of Build. We're very excited to see you here again today, and we'll just give folks a few more minutes to join. Um, and while we're doing that, let's have a little fun here. Since our special guest is from the BMW Group, I would love to know. It's a two-part question: the first BMW you ever drove, year and model, and your favorite BMW. And Konrad, I should just start by asking you that. I am sorry putting you on the spot, but you probably have driven a BMW before. What was the first one and your favorite one?
Ooh, the first one was the 7 Series from my dad in 1999. To be honest, I forgot the model code, but that was a
That's
really
a cool
nice
car.
one. Yeah, I mean, 7 Series always is great. But actually,
Mm,
since the i3 in 2013 was launched, I'm a big fan of electric driving. First, because of the one pedal feeling, and
mm,
second, because acceleration and silence are just great. So for a long time, I've only been driving electric cars now. The iX was my favorite, but I'm really looking forward to the iX3 that we just revealed. I get one in November, and that will just be the best EV
mm.
I've ever driven for sure.
Well, lucky you. Yes, I've been watching
Yeah,
the
true.
reading all about the iX3 and then the press release and all that kind of stuff. So it's very, very cool. Um, all right, so let's see. Anyone in the chat, do you want to let us know what is the first BMW you ever drove and your favorite? And maybe it's the same one. Let us know. Drop that in the chat, and we'll get started here in just a sec. And while we're doing that, actually, if you want to skip to the next slide, I will show folks a few things about our Zoom here. So this session and all the build sessions are being recorded, just so you know. And you can also access this recording and all the others throughout the week at the Zoom lobby page. So bookmark that and be sure to come back and watch the sessions you might have missed. Closed captioning is available for this session. So at the bottom of your screen, there's a CC button. It might be under More. You can click that and you can get captions in a variety of languages. And we will be taking questions. So use the Q&A feature at the bottom of the screen. You'll see a button there. Again, on my screen, it's under More because my screen's a little bit small, but you'll find it there. Click Q&A and ask us questions, and we'll try and get them during the session. And so, someone had an E30, and they had shocks in the middle bumper, so we played bumper cars at the stoplights. Yeah, I try and not bash my bumper into other cars, but maybe I should try that. I might have more fun in life. Okay, I think we could get going. So, if you want to go to the next slide, I'm David Snyderman. I lead product marketing here at Mapbox for automotive and navigation. And we are very excited here to introduce to you Konrad Hübner from the BMW Group. And Konrad is the director of navigation. We have a special place in our hearts here at Mapbox for the BMW Group. Many years ago, Konrad saw our vision and was our champion within BMW. And since then, we've built a great partnership. And we built some really cool innovation together as well, some of which you'll see right now. So without further ado, Konrad, I'll hand it over to you.
Thanks, David. So let's hop into it. I'm going to talk about our curve ahead view, as the title already stated, which shall help you to drive safe. And I'm going to start with a video that we produced to market that feature. So enjoy for a minute. Okay, so this is the feature, and it mainly, you saw it, shall help this small little fish which is a bit scared with respect to all the other stuff around it when driving there. And what I'm going to talk about now is how do we save her life with the curve ahead view in our cars. So this story mainly starts, as David said, quite some time ago. 5 years ago, we began the navigation development together with Mapbox. And back then already, I looked it up. It was like ticket number 46, which I created, that we need an eHorizon because if you drive in a car, I mean, you're on the road network. That's the one thing that is typically quite for sure. And what is ahead of you is really important in respect to driving. So it's a concept that has been there for driver assistance systems for a long time. And the Mapbox stack back then did not yet contain it because it came from visualization and mobile world. And so it was a piece that we just needed to add jointly in order to get many different features up and running. And what we always aim for is to build something flexible, so it shall not be use case specific, but allow anyone using the Mapbox SDK, which you can, as you all know, simply download in the web, to build things similar to what we build on top of it. So let's see how this works together with a curve ahead view. The first thing that you need to do is, of course, find curves. That's something that our data scientists do by using map data. We mainly crawl the map depending on road class, curvature, the allowed speed limit, typical speeds that we get from map providers, and also through data that we get out of our fleet to figure out if there are curves where you have to drive significantly slower than the legal speed limit and which have a certain curvature that indicates that it might be dangerous if you're too fast. So the first feature that we built was just that dangerous curve warning. It mainly focused on danger, and this extension that we built together with Mapbox is the positive side because curves are something people are looking for in the Alps, for example. It's a joy to drive there. So what we wanted to do is something that helps driving, similar to rally driving, but still gives you an indication of whether you're still safe or not. During that work, we also figured out that some regions are really curvy. So there's a high density of curves while others aren't. And that's also something to consider, the density of your data if you work with geographic information. Okay, so I have one curve for you. That's from a pillory. It's close to where we're living here in Munich, in the Alps. And this curve is the one we're taking as an example here. It's a really nice ride, but the turns are sharp. And so, and as you can see, the look ahead is also really bad. So if someone is approaching you or whatever is behind the curve, it's hard to see. So the first thing that we do is that we have to reference this to a map in order to be able to track it. This is the curve. It's the Tatzelwurm in the Bavarian Alps, if you ever want to go there. And that's where we now start our journey. So the matching to the map is already done client side because we need that truth for this one specific vehicle inside the car. We mainly computed a data product. We download it to the vehicle, and then we take that curve information and throw it at the Mapbox stack to figure out where on the map exactly it is. What we get returned is an edge. You can see the road graph as a graph with edges and vertices. And that's the type of information that is later used to keep track of it. So we know where it is, and we can also register for callbacks to get notifications whenever we're close to it, because that's what we need to know. This all is also direction aware because whether you come from one side or the other can make a difference with respect to approaching speed that you manage to do anyways. And we only want to give information to people when it's really necessary, so that like cognitive overload is minimized as much as we can. So how does that look like? First thing is that we prepare the matching and tracking. The thing that is used is a road object matcher observer from Mapbox. The name states it all. It's used to observe the matching results of objects that we throw in. There can be errors, of course, but if it succeeds, we get a road object back, which is referenced to the map. And so the navigation SDK does know where this belongs to with respect to the current valid road graph that the SDK is using. And the next thing is that after getting that matched object, we throw it at the road object store, also from Mapbox Navigation SDK, and say, hey, this is a custom object that we bring with us and that we now want to track. And second thing is, of course, you need to register this observer with a matcher so that we get those callbacks once we start matching something. So now we're prepared to do that matching. So now we get our data from the backend and request matching to the map. This is quite simple. You can create different geometry structures. A very simple one is a point. You give it an ID so that you understand what was referenced now when you get the callbacks. And you can provide, as an example here, a point with latitude and longitude in WGS 84, plus the direction if you want it to be tracked as well. A second option is that you can use OpenLR. That's an open referencing standard that gives you way more meta information when you try to match something. So I mainly took 3 coordinates of the curve that you just saw and let it run through an OpenLR encoder. And this is the base 64 encoded string that gives additional information beyond the coordinates. What is typically done there is that you can also add things like the road class and other information about the road network if you know that at the point of data creation. And this allows the decoder and matcher to reference it more reliable to the map. One great example is in Japan, where roads are stacked 5 times on top of each other. So a coordinate is not precise enough to really understand on which road this is now happening. In most cases, that's no problem, but there are edge cases where you really need it. So that's why we asked for it right from the beginning, and it was added by Mapbox. So now we have those 2 curves. And we take the road object matcher and just say, match those objects, please. There's, if you notice precisely, there's 1 bug in my pseudocode I just noticed. It was late yesterday. The second one is no point object, but it's a line object. So the matcher hopefully would complain, but you can throw both at it and it will now try to match it and send you callbacks after that has succeeded. But that's what we're going to look at later. Okay, next thing is that, of course, after knowing where on the map we are, we also need to understand where we're going. So this nice intersection, AI generated, is one where we're approaching it with our car now. And the big question is, do we take the left or the right turn? And if you want to inform the driver with respect to some information, you somehow need to decide or not decide and then present both. But typically, we only want to give information to drivers when they for sure will approach it, because those false alarms mainly result in people not paying attention to those warnings anymore. And that's what we definitely want to avoid. Yeah, so this one now decides to take the right turn and continues its journey. And the SDK tries to figure that out in advance. So looking at this screen, which is taken from the X3, not the new iX3, the X3 that you can buy since mid of last year, that's a road, and you see some intersections coming here where the water is. And we have a debug view to visualize the eHorizon because, of course, we wanted to understand how it behaves and what it does and tweak our experience on top of it. So if you turn on that visualization, you see the purple line, and the purple line is what we call the most probable path. So compared to all the branches, it has the highest probability. And that probability is something that the SDK decides upon based on different factors. Typically, if you don't have any directions active, that's based on road class, because that's the best guess. Yeah, if you're driving on a large road, the probability that you stay on it is rather high. But you do see those side branches in green where there a certain piece of the probability is considering that you take this. And that's also why that purple line here gets thinner. So we know that we're not fully sure if we will reach this location, but we are 100% sure that you reach this location because there's no branch up front, and we do not consider you now doing a U-turn and driving back. And that branch expansion is limited. You see that it stops here because it's quite expensive. If you do it on a road like this, it's easy. But if you do this in downtown Manhattan, there are just tons of sections where you could go. And that is computationally expensive and can impact performance. So inside the SDK, you can configure how far that branch shall be expanded and also how long at all in the distance you want to look. So if you now turn on guidance, the customer planned a route to here, it gets way easier because we can, of course, assume that you exactly follow down that path and don't go anywhere else. So the most probable path in case of active guidance is identical to the route. You might still deviate because you think you know it better than the navigation system, but that's something that we don't anticipate for implementing features like this. And after the deviation, the eHorizon would immediately adopt. So that also should not be such a big problem. Okay, so now we know where you want to go. And if you now approach such a curve, and we want to let you know whether you have to pay attention or not, and maybe drive slower. Now we need that information from the SDK if you are approaching such a curve. And that's what we look at now. There's this eHorizon module from the navigation SDK, and you can implement an observer, which mainly gets all the callbacks from the stack once things happen. It has some more methods, but the one that is really relevant in our case is the position update. So whenever you mainly inject a new input position into the SDK, it calculates where on the road graph you are presumably now, and then computes all the other things on the eHorizon in the background and gives updates to you for all the objects that we before handed in order to get notified when we approach them. And the relevant method for us is this position update, where we get a list of road object distance infos. The name is quite self-explanatory again, that we're heading towards now. And you can then iterate over them and figure out how far is it from my current location to the start of that object. And we decided that if you're less than 200 meters, we want to show that curve info. There are other methods, especially for line objects. Imagine a speed control section where you can say, okay, now I entered this section, or now I exited it again, because there's this state of being in it. And that's something that you can then also keep track of. So that's all that it needs to get those notifications and callbacks after you've registered something with the SDK. And you can put your visualization business logic on top of it. More code is not needed. And that's mainly also the power of the SDK, which makes it so easy and simple for you to implement great features with very little own coding efforts. And you can focus on the experience side and don't have to worry about all the logic to do this. It's not always straightforward, and also to do that in an efficient way is tricky. And we're very happy that the SDK just fully takes care of this. So looking, this is now the registration, of course. You need to register your observer to get those callbacks, but then they just flow in and you get those notifications. This is then how it looks like, as you saw in the video. We mainly have the road here ahead of you, and there's an arrow indication with respect to the strength of the curve. So rally-like, is it very curvy or not, and how far? This is the distance to start that we just looked at, how far it still is until you reach it. And you see that yellow glow. That's mainly our warning indicator based on your current speed and our assumed safe driving speed through that curve. It can turn red, But if it's red and you still race like this through the curve, it's really something you should only do with good tires and dry roads and absolute control over your car. Another thing where we use the Mapbox SDK is this road graph here. And funnily, it's an empty map style. Yeah, so we use the map renderer. But what gets visualized is the eHorizon. And instead of drawing it in purple, we mainly use runtime styling, which is also extremely powerful to generate some 3D looking road surface with outlines that mimics a good looking road, but only the one that is relevant for you again. So it's a second use of the eHorizon and the geometry that it returns and is used for the visualization inside the heads-up display. So exactly where you're looking at right now so that you can fully concentrate on the road and are not distracted by the rest of the system. That's a lot of flexibility that we have there. And I never thought that we would work with an empty map style where Mapbox Studio is so great to design beautiful maps, but sometimes less is more. And that's one of those examples. There are more use cases that you can put on top of them, also road safety related. One is obviously speed cams. Mapbox offers its own product. We also implemented it ourselves, similar to the curve ahead view. A second one is a pothole map. That's especially important in the US, where the roads are sometimes really shaky and it can have bad impact on your tires and bumpers. So that's why, and suspension. So that's why this feature is live there. And it's all mainly the same pattern that we do here. And last but not least, that object matching is also used for on-street parking. You see those blue lines. We mainly put those lines in the SDK and say, please match them for us. And we get the geometry back, which perfectly fits the map, and then use runtime styling again to shift it to the size. So mainly that hack of a road object matcher is used to ensure that the visuals are looking really great and the lines are not feeling totally detached. So that's mainly how this feature works and how we build it. And the key takeaways for you is the Mapbox SDK is extremely flexible there and powerful with respect to any road graph related features. That's something that evolved tremendously over the last years. And the things that you want to check out in the documentation are those road object matcher, the road object store after you match them, the graph accessor to get access to those edges from the eHorizon and get the geometry and all that information, and the eHorizon observer itself. Then also that eHorizon and the object tracking mainly allow you to do very, very different things. You can think about gamification, about any other features where you just want to properly align things on the road graph and get triggers. So it's a thing very quickly allowing you to implement functionality. And last but not least, in some regions, there are really many curves that surprised us. We use mainly tiles in order to download them. And you should always pay attention to the amount of objects that you try to track at the same time, because it can lead to unexpected trouble. We ran into this where there mainly were so many curves in a certain region that only when people drove there, we ended up actually in a crash doing testing. We figured it out before it was delivered. But that's something that can happen if you just flood the system. Nevertheless, implementing the curve ahead view was really a pleasure based on the Mapbox stack, and we're happy to continue our journey in the Neue Klasse with the iX3 also on top of the Mapbox stack and see what we will do there. Thanks.
Konrad, that was very cool. I'm glad the goldfish was okay as well. I was a bit nervous. Um, we have some questions, a lot of questions actually. This is a really interesting feature. I'll start with a few easy ones. Does the curve ahead feature work offline?
Well, it's cached. So because I mean you're right, typically that happens in mountains and you don't have connectivity there. But based on Mapbox predictive caching, we mainly fetch map areas ahead, and we also prefetch quite large areas with those curves. So that should also work in areas of little connectivity, but typically we assume that the vehicle is online.
Okay. Um, Another one you mentioned the information and being very careful about what you show to drivers, not wanting to overwhelm them and lose trust and false alarms and so on. Can you talk a little bit more about how you find that balance? Maybe that fork in the road and how you know which way they're going to go, or what kinds of design decisions your team grappled with in designing a feature like this?
So first place, I mean, you can also deactivate it if it annoys you. Yeah, so it's nothing that we impose on people. But second, and that's when mainly when we generate the data product, our data scientists, of course, look at all the information that they derive from the map. They can visualize it and then figure out if they think this is too much or not. And I mean, we're a car company, so we do a lot of drive testing. And our friends from the driver assistance side and driving functionality who mainly own this feature, they of course know the dynamics and have a good feeling of what is dangerous and how to parameterize that. And so we put quite some effort into that to reduce the number of curves. But still keep enough in so that you can also properly make use of the feature. Because if you never see it, it's also useless. Yeah. So it's a lot of
Hmm.
try and adjust.
Hmm. Any feedback from users so far, or some stories that you've heard of that how this feature has helped out in real life?
Uh, People typically, unfortunately, only come back to us when they have problems. So luckily, we have not heard so much about this. But there's one review from a guy called Car Maniac of the iX3. They were allowed to do drive testing in some time ago in southern France, and they accidentally hit that feature and were positively surprised and said, "Oh, it's indicating how strong the next curve is." Yeah, so that reaction, I think, gives a good view on how that behaves. I guess you don't really miss it if it's not there, but if you know that it's there and you enjoy driving curves, then it's something that's definitely worth testing out.
Hmm. What is the curviest region? I think you might have shown it to us in the Alps, but was there something during development that you thought, wow, this road is pretty crazy. I should go drive it?
Um, to be honest, I can't remember anymore. I didn't look at the entire data product. I do remember that we had problems in the United States somewhere where we hit that limit of objects we can track.
Mm.
So yeah, we might be able to look that up later, but I'm unfortunately not aware.
I'm putting you on the spot here with a few. Um, Someone else had picked up on the parking feature. You mentioned that briefly, where you show on the map the blue lines. Is that
Yeah.
available street parking? And if so, how do you know where these available spots are?
Yeah, so I mean, only our cars don't manage to generate that. It's also out of historical knowledge, of course, and we work with a partner there. And it's mainly a probabilistic model, which gives you an idea of on a certain day at a certain time, how high is the on-street parking probability. And the lines that we highlight are the top 30% of those streets, so that we try to guide you to roads where the chances are really high. In addition, that feature also highlights parking garage and if you have an electric car charging stations. So it's part of our arrival experience where we try to help you get rid of your car when you want to exit it again. But it's mainly not available everywhere, of course, only in very dense regions in metropolitan areas where you really have high parking pressure. And that's where we do it together with partners.
Very cool. One last question. I guess it's back to the origin story. Someone writes, "How did you first choose to start working with Mapbox? What was that process like? How did you decide, and how has it been?"
Yeah, that's really funny. Now I'm going to tell it in public. I told it Peter Zirota, or the Mapbox CEO, once. It's literally the case. I sat on my sofa in the evening when we started working on an Android-based head unit platform and was searching for a navigation SDK that also supported x86. And that was mainly the reason why I stumbled upon Mapbox and then figured out, oh, with that SDK, it mainly took 3 days to get some running prototype. I mean, of course, that's far away from the product, but this idea of having a productized SDK as a developer product, which is worldwide and publicly available, was an indication of robustness, yeah, and the clear will to deliver something which is useful for people out there beyond custom projects. And because those custom projects typically, I don't know, end up in its limits and resource challenges and I don't know what. And that's when we mainly started digging deeper. And eventually I reached out to Mapbox and said, okay, we now want to investigate cooperation in more depth. Let's talk about it. But that's how it all started. And that's still the case. That's the great thing. So after those 5 years, everybody out there can still download the Mapbox Navigation SDK and they get the same that BMW gets. And all that you see is something that my team then put on top of it. But there are no specialities. It's all documented. It's a self-service thing. You don't even need to talk to Mapbox necessarily. I mean, it of course helps. We enjoy it a lot in order to plan future features and road mapping and do joint optimizations. But generally, this all works without even getting in touch. And that's what I incredibly like out of my developer heart, because that's what developers are looking for. Something that is stable, robust, documented, and available just out there as a use it as you need model.
Very cool. Thank you for sharing that. And thank you for spending your time with us here today. We're very much looking forward to your launch of the new vehicles. And for folks who already are lucky enough to own one of these cars, I hope you enjoy using the curve ahead feature. Thank you for explaining how that works. And I think that will do it for our session here. Thanks for joining, everyone. We'll see you at the next one.
Thanks for hosting me. See you then.